In this lecture we can learn about the TCP congestion control. So we know that what is TCP. So TCP belongs to the transport layer and it is called the transmission control protocol. So the main duty of the transport layer is to take the entire data from the source to the destination, and it maintains a flow control, and also it gives us a good reliable service. So due to the nature of the environment, we can say that at certain situations the network will be getting congested when more data packets try to flow through the same router towards same destinations. Then congestion will take place, and we need to prevent it. We need to regulate the data flow so that we can able to minimize such congestions. So automatically we can able to minimize the delay. So for that we are having certain congestion control methods like additive increase, slow start, and retransmit. So these were the congestion control methods we have in TCP. So congestion control refer to the mechanism and techniques to control the congestion. TCP uses the congestion window and also the congestion policy that avoid congestion. So now we can say that the scenario comes like if the network cannot able to deliver the data as fast as it is created by the sender, then it will come across some kind of delay, so that we need to minimize the data packets from the sending side. So the congestion policy in TCP, here we can say like a slow start phase. So here start slowly and increment exponentially up to the threshold level, and in the congestion avoidance phase, after reaching the threshold, increment by 1. And in the congestion detection phase, once congestion is detected, the sender goes back to the slow start phase so that we can able to avoid a congestion. So these three are the very determined congestion policy we have in TCP. So slow start phase means after the threshold level we can able to slowly keep on increasing the data packets, and until the congestion is detected, and thereafter it will be decreased, so that we can able to maintain a good data regulation, that is the data packet flow. So first what we have is the slow start and exponential increase. Here in this phase, after every round trip time, the congestion window size will be incremented by that is the value 1, and this incrementation is done exponentially. So initially the congestion window value will be 1, and after one round trip time, what is meant by round trip time, that is if one data packet is moving from the sender to the receiver, and after it has been arrived to the receiver, now the time taken for the second data packet to transfer from the sender to the receiver, that is sending on data and getting the acknowledgement for that, and this time sequence is called as round trip time. And after every round trip time, the congestion window will be increased exponentially. So at first it is initially 1, then it will be becoming 2, then it will be becoming 3. So incrementation is done exponentially, so that we can able to increase the data flow, that is data packets. So this approach we can see from the diagram. So one side we are having the congestion window. So the congestion window based on, for example, if the window size is 1, we can only send one data packet. If the congestion window packet is 2, if the window size is 2, then we can send 2 data packets. And if the congestion window size is 4, we can send 4 data frames. So this is the mechanism we follow, and schematically we can able to easily understand by representing this diagram. So this exponential ingress will help us to manage the flow through different nodes available in the network. So this was represented in this form. So after one round trip time, what is the nature of the congestion window and how it is getting incremented. Then another method, that is congestion avoidance phase, that is additive ingress. So there we found exponential ingress, but here we say about that is additive ingress. First, initially, for example, the congestion window is 4, so we say 1, 2, 3, 4. The initial increment value is 4 now, and after the round trip time it is getting incremented, that is plus 1. So in the additive ingress, first 4 data frames can be sent and we got the acknowledgement. Thereafter, second time the congestion window is increased just 1, I plus 1. Again 5 data packets we can able to send and we can get the acknowledgement. Thereafter we can able to again plus 1. So likewise we will be keeping on the way, that is additive increasing. So such is the kind of, so when the I value is 4, it will be getting, each time it is getting incremented, so that we can able to send more data frame throughout. So initially the congestion window value will be I, and after one round trip time it will be incremented the initial way, that is I plus 1, and the second time it will be I plus 2, the third time it comes as I plus 3. To avoid congestion before it happens, we need to keep the phase, that is the phase starts after the threshold value is denoted as slow start threshold. When the size of the congestion window reaches a slow start threshold, then we need to go for the slow start phase, that is the phase will be temporarily slowed down, and we need to again increase the data packets. And in the congestion reduction phase, once it is directed, we can say that multiplicative decrement, the congestion window size will be decreased. And retransmission is also possible to recover the missing data packet, which will be dropped by the router due to congestion. So TCP supports retransmission, and retransmission will be occurring in two ways. One is when the timer times out, or when 3 duplicate acknowledgements are received. So on these circumstances, we can able to resend the same data packet which we already sent. So the retransmission due to timeout, in this case congestion possibility is high, that is we found that the situation is very critical, that is timeout, and the slow start is reduced to half of the current window size, and we can able to set the congestion window as 1 and start with slow start phase again. And retransmission can be possible with 3 acknowledgement, that is duplicate. So here again the congestion possibility will be less, and the slow start threshold value will be reduced to half, and we will again set the congestion window as a slow start threshold, and we can able to start with congestion avoidance phase. So these were the data and information you need to understand from this congestion control in TCP. So that's all in the class today.